All right, hello again, everyone. A little after 1, we got 1:05 on my clock, so we do have folks still logging in, but I want to go ahead and get started to be respectful of everyone's time. So thanks for joining us today, and welcome to NEIWPCC's UST Inspector Training webinar series. My name is Drew Youngs. I work at New England Interstate Water Pollution Control Commission, and today I'll be moderating the session. Most of what we're going to be discussing is around PEI RP 1200. We're going to focus on concerns with UST sump testing. So to introduce today's speakers, we have Ed Kubinski. He's the Director of Regulatory Affairs, Training, and Certification at CROMCO. Lauren Swalheim is the Global Training and Assurance Manager from Franklin Fueling Systems. Natalie Creed is the Hazardous Waste Compliance Manager from Idaho DEQ. And Heather Peters works on UST compliance and technology at Missouri DNR. So before we get into training today, just want to go over some WebEx 101 to help you navigate the system as part of the audience. So as you could probably tell, those of you that have called in, your phone is on mute. That's just to reduce any background noise we might have otherwise. And to communicate with me, if you do have questions about using WebEx, or more importantly, if you have questions about the training today, any questions for our speakers, feel free at the top of your screen. You should see a little chat bubble, and you can click on that at any time. Feel free to, again, send me those questions using the chat function. If you are in full screen, if you just hover your mouse toward the top of your screen, you should see access to chat and a handful of other controls that you can use to participate in the webinar. Our speakers will sort of prompt me to take questions today, but at any time, if a question comes up, feel free to send it my way, and I'll hang on to it until my speakers let me know it's a good time for questions. So fire away. Friendly reminder, I think most of you are aware, if anyone has not been to our website, we do post the recordings after the trainings. Usually it'll take me a week or two to get that up there, but keep your eyes peeled. We will post that webinar. The site is right there, or you can just find it from navigating from NEIWPCC's homepage. It's just newepc.org. Also want to give you a heads up. If you could, please do take part in our survey. You'll automatically be prompted to that survey at the end of the webinar. It gives you, a chance to help us out in terms of planning future webinars, but I know many of you in the past have asked NEIWPCC to confirm your attendance in the trainings, and so if you want to not be anonymous and put your name into that survey, it'll help me after the fact confirm that you were on if that's something that you're interested in. So getting into the training for today, we're going to cover a handful of topics with our speakers, qualifications and procedures for sump testing, as well as concerns with testing, test procedures for double-walled spill buckets, and we'll hear from Lauren getting feedback from Franklin Fueling Systems. And we'll also have Heather and Natalie talk about state considerations for handling post-test fluid. So I want to go ahead and hand it off to Ed Kubinski for the first part of the training. And again, Ed is the Director of Regulatory Affairs, Training, and Certification at CROMCO.
All right, good afternoon, everybody on the East Coast, and good morning to those of you on the West Coast. For those of you who don't know CROMCO, we're a large testing service provider, UST testing service provider primarily on the East Coast. If you haven't heard or you've been living under a rock, you know we have new EPA regulations that we're going to need to deal with. So we're gonna get into talking about the sump testing and spill bucket testing that's coming up. There's a number of changes that have been included in the regulations, including overfill, checking the overfill equipment in the tanks, checking ATGs, monthly walkthrough inspections. We're not going to be covering that. We're going to be focusing on spill bucket testing and containment sump testing. All right. All right. So what you're going to need to do, you're going to need to get familiar with the new standard, PEI RP 1200. RP 1200 has been developed since 2010. It began development. A committee was appointed by PEI in 2010 in anticipation of these new federal rules, and we were hoping to get it out, in plenty of time before the new regulations. We did get the document out in August of 2012. It was published. As you know, the new EPA regulations didn't come out until 2015, so we were well ahead of the regulations. And then we actually just finished reviewing comments and making revisions to the document. So we had a comment period that was open from July of 2015. Comments were due by January of 2016, and just a couple months ago in December, the committee got together, reviewed about 100 pages worth of documents, and the 2017 version of RP 1200 will be coming out very shortly. So that's a little bit about the timeline of the document. The document does cover everything with the new federal regulations, overfill prevention, leak detection sensors, doing the automatic tank gauge, testing electronic and mechanical line leak detectors, spill buckets and containment sumps, which is going to be our focus today, tank and piping interstitial testing, shear valves and e-stops. It's all covered in that document, so you can use that document to reference all those standards or all those tests. I am the chairman of the committee, so I guess the buck stops with me. And you can see all the different members of the committee. We had a good group of owner-operators, testers, installers, regulatory agency, all involved in developing the document. And then we just recently added a couple new guys to the committee, including Mike Frank from the state of Maryland, who took over Paul Miller's place as the regulatory body. So Chapter 6 of RP 1200 covers spill bucket testing and containment sump testing. So with the new federal regulations, the first routine test for spill bucket testing in most of the SPA states has not been determined yet. However, the EPA regs do go into or have gone into effect in the non-SPA states. I'm assuming everybody knows the difference between SPA and non-SPA states. So if you're in a non-SPA state, the first test of spill buckets is due by 10/13 of 2018. So when we're doing testing of spill buckets, we're going to want to follow manufacturer's guidelines, RP 1200, which is an industry standard, or if the state develops a standard of its own, you can follow that. New buckets installed after the onset of the rules need to be tested at installation and then periodically thereafter. Unless they're a double wall spill bucket and being monitored monthly, then the EPA rules say that those buckets would not be required to be tested. However, single wall spill buckets are going to need to be routinely tested, and double wall spill buckets that are not being periodically monitored are going to need to be tested. Testing is not applicable for the stage 1 vapor buckets per the EPA. However, each state is going to need to determine that on their own, and you'll see in a few slides what I'm talking about there. So we'll start out with the hydrostatic testing of the spill buckets. As you can see here, we have some plumber plugs installed in the fill risers. Drop tubes have been removed. Spill buckets have been cleaned out. We find all kinds of crazy stuff in the spill buckets. Beer bottles are not uncommon either, but we want to clean these spill buckets out as best we can before running a test. So here's what it says in RP 1200. You're going to clean, inspect, and repair any defects of the bucket before running a test. You can leave the fill adapter and cap on when you do the test. RP 1200 has given the testers and the owners latitude to make a determination if they want to run the test with the fill cap installed, or they can remove the cap and adapter, and you can use a plumber's plug and seal down below the drain so you're testing just the bucket. Obviously, if you're allowing the drain valve to be installed during the test. You want to make sure that the drain valve is leak tight before doing the test, or remove it and seal it. You're going to fill the bucket to within 1.5 inches of the top of the bucket. You're going to use a straight edge and measure the water to 1/16 of an inch. You're going to wait 1 hour, and then pass or fail criteria is 1/8 of an inch drop over the course of an hour. If it drops 1/8 of an inch or greater, the test is considered a fail. So here's some things you want to look at when you're preparing to run a spill bucket test. You want to look for any cracks or holes in the spill bucket, small cracks. You know, large cracks like this, you're not going to want to run a test just to confirm a failure. Obviously, the spill buckets have most likely contained fuel, so you don't want to put water in there and knowingly, you know, let it release into the environment. So this is something that we would consider a visual fail. We would fail that spill bucket just on visual confirmation, you know, let the owner know and provide a test result to the customer and regulatory agency. Now, some of these spill buckets that you're going to come across are going to be difficult to do a good visual inspection on, as you can see here. And this is going to cause problems for these monthly visual inspections as well. So some of these spill buckets are very hard to, you know, do a visual inspection. We're going to have to maybe use a mirror and a flashlight to get in there, intrinsically safe flashlight for safety purposes. So try and inspect them as best you can. And then if you're leaving the cap and adapter in place, this is typically what you're going to see when you're running your spill bucket test. Fill it up to within 1.5 inches of the top and run the test for an hour. Now, in the back of PEI RP 1200, we do provide some sample forms for documenting these tests. So if a state is looking at developing their own forms, you can look at the RP 1200 document. You know, all the testing companies, you know, us included, you know, we have our own forms. You know, these things may be changing over the years. I know a lot of states are considering developing their own forms. The state of Maryland just came out with their own form just a couple days ago, and we're going to have to look at including that into our system. So moving on from hydrostatic testing of spill buckets, now I'm going to get into another option that you can do for testing spill buckets is vacuum testing. Advantages of vacuum testing is it's a much quicker test. And obviously you don't have to deal with the water disposal issue that you deal with when you're doing the hydrostatic testing. Basically, you're putting a plexiglass plate with a gasket underneath it on top of the spill bucket. You could see, let me see if I can get my laser pointer out here. Right here is a small venturi hooked up to our nitrogen bottle, which creates the vacuum. And then we have a magnehelic gauge here measuring inches of water column. Basically, if you're doing vacuum testing, you're going to do the same thing you do with hydrostatic testing. Clean, inspect, repair any defects with the spill bucket. You can leave the cap and adapter in place, or you can use some type of plumber's plug to isolate the tank from the vacuum test. Make sure your drain valves leak tight. Put the cover on. It's a single wall spill bucket. You're going to apply 30 inches of water column vacuum. RP 1200 says hold it for 1 minute, and as long as the vacuum level is above 26 inches, after that 1 minute, the test is considered a pass. Here's some more pictures of primary testing, spill bucket testing of a primary bucket. Here's a single wall bucket. You can see there's a cap installed on the fill riser to isolate the tank from the test, and a little bit better picture of the small venturi that we're using to create the vacuum. 30 inches of water column vacuum, can't drop below 26 after 1 minute. So if we're testing double wall spill buckets, some of the manufacturers who you'll hear about a little later in the program here, but we have a general guideline for testing the interstitial space of double wall spill buckets. Again, clean, inspect, and repair any defects. You're going to attach your hose to the secondary access point of the spill bucket. And when we're doing the interstitial, we're only going to apply 15 inches of water column vacuum as opposed to 30 inches for doing the primary. Again, we're going to hold for 1 minute, and after 1 minute, as long as the vacuum is 12 inches or better, the test is considered a pass. So some questions that are some things that you want to consider, as you're, formulating your regulations over the next 18 months or so. What about double wall spill buckets that are not being monitored? Obviously, EPA says that they're going to need to be tested. So I use Maryland as an example here. So the state of Maryland, who we routinely do business in, we've asked them, is the test of the primary spill bucket acceptable in Maryland? And actually they say no. We must test the interstitial space of a double wall spill bucket in Maryland. That's what they require. Other states are going to need to interpret this and provide guidance to owner-operators and those doing testing in your areas. All right, some of the spill buckets, double wall spill buckets, they have, there are electronic sensors and there are also mechanical gauges installed in them. So if the bucket's double wall, then it's monitored monthly. According to the feds, no periodic test required. However, state of Florida just came out with their new rules. Double wall spill buckets still have to be tested every 3 years. Maryland, we're testing the interstitial annually. Other states, what are you going to do when it's your turn to formulate your regulations? Another caveat that we run into, if the bucket's double wall and it's monitored with a gauge, a couple states are requiring that the owners verify that that gauge has to be checked for proper operation once a year. State of Delaware, state of Florida. So we need to physically remove the gauge. This type of gauge, we have to dip in a cup of water and make sure that the gauge is functioning properly, and then reinstall the gauge back into the double wall spill bucket. Again, what are other states going to do with this? Something to think about. As I mentioned earlier, we do see spill buckets installed on the stage 1 vapor recovery port of your gasoline tanks. According to EPA, no test is required for the stage 1 vapor. State of Maryland says yes. What are other states going to do? This is a question that routinely comes up with our customers and that we need to have the answer for. So be prepared to provide guidance on these things as we move forward. Also, what about testing a spill bucket in a containment sump? You have a sump underneath the bucket. Do we really need to test the bucket? You're going to need to provide some guidance on that. These are some things that we typically see out in the field. So I'm going to stop here for a moment. I'll take a question or two about spill buckets, Drew, and then we'll move on. We'll also have some time for questions at the end. But while we're finishing up on spill buckets here, I figured I'd take a question or two.
Sure. Well, thanks so far. Ed, I do have a question. It might actually be more appropriate for EPA, but it might also just be a clarification on what you said. So I want to ask about testing, the date, so October 13 of 2018. What they're asking is, do states need their regulations effective by then, or they actually need to be testing by then?
For the non-SPA states, the states that don't have program approval from EPA, your first test of your spill bucket would need to be done by 10/13 of 2018, unless the state changes their regulations prior to that. For the states that have SPA, that date will be determined by the state.
Okay, thank you. And that's all for now.
Okay, we'll move on from spill buckets. And next thing we'll cover is containment sump testing. So currently in most states there is no periodic requirement to test containment sumps. There are a few states, Maryland, Delaware, Massachusetts, that we deal with, that there are some testing requirements. However, with the new federal rule, that rule is requiring containment sumps that are being used for interstitial monitoring for release detection for your double wall piping. You're going to need to test your sumps and under dispenser containment for tightness every 3 years to comply with the new federal regulations. Again, just like spill buckets, you're going to follow manufacturer guidelines. You can use RP 1200, or if the state develops their own standard, you can follow that. And we'll get into some of the different standards by state a little bit later. Or you can use a double wall sump or under dispenser containment sump, and you can monitor the interstitial space of the containment sump monthly. That would get you out of the periodic requirement to test the sumps. On the East Coast, I haven't seen any double wall containment sumps going in just yet, but I'm sure they're going to be coming. For new installations, this goes along with spill buckets as well. New systems are going to need to be tested at installation, and then at least every 3 years after that, depending on what the state determines. So one thing I wanted to bring to your attention is that a number of states mandate the use of interstitial monitoring for piping release detection after a certain date. And this in turn is going to mandate that these containment sumps are tested. I'll use my home state of Pennsylvania, for example. Pennsylvania, we are, any new piping installed after 11/10/07 has to be double wall, and you must use interstitial monitoring for release detection. So there's no other options for release detection for piping after that date. You must use interstitial monitoring. So you're going to be relying on those containment sumps to contain a release until it's removed from the sump. So we're going to want to make sure that those containment sumps are liquid tight, and we're going to have to test them. Now, for double wall piping installed prior to that date in Pennsylvania, there are still other options available for release detection. So you can you can use interstitial monitoring. You can also use annual line tightness test. You can use SIR. You can use vapor or groundwater monitoring, all the other options you've had for release detection. And if you're using an option of release detection other than interstitial monitoring, you're not going to have to test your containment sumps because you're not relying on the containment sumps for release detection, and that's the way the federal regulations have been interpreted. Only if you're using the containment sumps for release detection purposes are you going to have to test it. But there may be different interpretations of that, and maybe some states, will still require containment sump testing no matter what the federal regs say. Remember, the federal regulations are just the baseline. They're the minimum that you have to comply with. Some states are going above and beyond that. But when we're doing containment sump testing, if we're following RP 1200, again, clean, inspect, and repair any defects in the sump. You're going to want to seal off the piping interstitial. We've had a number of questions over the years. Can you test the containment sumps as one continuous system from dispenser all the way back to the tank? In RP 1200, we specifically say you need to seal off the piping interstitial in order to do the test. We do not want to flood the secondary piping with water when we're doing this test. You're going to need to remove the sensor. We're going to fill the containment sump 4 inches above the highest penetration or sidewall seam. Again, just like the spill bucket, measure to the 1/16 of an inch, wait 1 hour, and the pass-fail criteria is 1/8 of an inch or greater is considered a fail. 1/8 of an inch or greater loss in the containment sump over the course of an hour is considered a fail. So again, you're going to want to take a real good look at all your penetration fittings and your sump seams prior to doing the test. Obviously, something like this, you're not going to be able to test it because you can't seal off the piping. Here we see bad boots. These are typical things that we see when we're going out to do testing. And in these cases, you're not going to want to run a test just to confirm the fail. you're going to want to get that repaired and ready to test properly, not just throw the water in there so that it gets into the secondary containment. So again, more pictures of what we see when we're going out to do containment sump testing. Make sure you take a real good look at these sumps before running a test. Electrical conduits are often a problem as well, and you know, we've run into some cases where we're actually filling up above electrical conduit junction boxes. We're going to need to make sure that those are able to be sealed off properly as well. We don't want water getting into the electrical conduits. So once we've done a good inspection of our sump and we're ready to fill them with liquid, here we are filling a dispenser containment sump. We're going to fill it 4 inches above the highest penetration or sidewall seam, measure it, and run our test. Again, RP 1200 provides sample documentation that you can use when doing the testing. Now we get into the questions again, what about testing sumps that contain spill buckets but no piping in them? So there's no piping leading out to the dispensers under this containment sump. Does it need to be tested? According to EPA regulations, no, because it's not, this sump would not be being relied upon for release detection. However, other states have said yes, you know, we want all sumps tested. Other states, so you're going to need to make that determination when you're coming up with your new rules. Another picture of what we typically see. So I'll stop right here and take a question or two on sump testing.
Sure. So thanks, Ed, and thanks to the audience, everyone. We've got a lot of questions here, so you know, I do have a running docket that I'm keeping. There's no way we're going to get to all of them today, but I will try to cherry pick a few out of here. So let's see. If you fail the vapor test, can the owner turn around and use a hydrostatic test to try and pass, or do they have to stick to the vapor test? That's a great question. We have that conversation with our customers. Just a note about vacuum testing. That, you know, in our experience, it's a little bit more difficult to pass a vacuum test than it is the hydrostatic test. So a lot of customers of ours will ask us to run a vacuum test of the spill bucket, and if it doesn't pass the vacuum test, then we'll run the hydrostatic test, and if it passes the hydrostatic test, it will be considered a pass. Great, and then another one here. So this person finds many composite spill buckets with cracks between the fill riser and the drain in the hex portion, and they're wondering if you found many of these and how has testing gone in comparison to the size of the cracks. I don't have any information on finding too many cracks on the drain valves. I haven't seen pictures from our techs on that, and I'm sure it happens, but it hasn't been brought to my attention. So I'm not seeing it a whole lot. Okay, and we'll see if we can fit one more in. So is spill bucket testing with coaxial VR drop tube different than without it? No, it's not. It would be the same. Okay, great. Let's keep moving. All right. Well, I got quite a few slides. I got about 30 slides left, so we'll keep pressing forward. I'm going to share with you some of our solutions to the hydrostatic testing problem. You know, everybody's like, well, how do I fill them with water? Do I run a hose from the site, fill up the sumps? Do I bring a tanker truck in there and drop the water in? Promco has what we call water wagons that we trailer the water to the site, drop the water in, and remove it after testing. So our water wagons have gone through changes over the years. These are some of our older water wagons, but this is the latest and greatest. It's about a 500-gallon tank that we fill up with water. We trailer it to the site, use the water for a couple tests, and then dispose of it. So what we have back here at our yard, we have a large potable water tank
where we have clean, fresh water that we use for testing, and we can somewhat rapidly fill up our water wagons. And then we also have a 5,000-gallon trailer in our yard here where we pump the dirty water after containment testing into the trailer, and then we have a back truck company come out and clean that trailer out periodically and properly dispose of the water after testing. I know that Natalie and Heather are going to get into the water disposal questions, but I just wanted to share with the audience that's how Promptco handles hydrostatic testing of containment sumps. I'll take a question or two real quick on that. If not, we'll move forward.
I think we're all set on that for now.
Okay. Okay, we'll keep going then. All right, I'm going to share with you some data that we've run over the course of several years, specifically with the state of Maryland. We've been doing containment testing in the state of Maryland since about 2004, 2005. Maryland was the first state that I was aware of that came up with a hydrostatic containment testing protocol. They just updated their protocol and developed a form just a couple days ago, as I mentioned. And the RP1200 protocol was based very much on the Maryland containment protocol. So when we started testing back in 2004 and we ran our data, when we first started doing spill bucket testing, this is what we saw. As everybody can imagine, we saw, quite a bit of spill bucket failures in the beginning, but over the course of time, things have gotten better. Equipment manufacturers have made great strides in, making their equipment better, lasting longer, and passing the tests more often. Here's some data that we compiled on containment sumps, fiberglass tank top containment sumps. We saw just a little bit better than a 50% passing rate when we first started testing, but as you can see over the course of the years, things did get better. So these are all passing percentages, just so you know, passing percentages of tests. Your high-density polyethylene sumps didn't fare quite as well as the fiberglass sumps. We saw just over a 40% passing rate when we first started testing back in 2004, and we're up around the 90% passing rate right now. Again, dispenser sumps, not even 50% passing rate in the beginning. It will be a little bit painful in the beginning. I presented with Bill Logue from Technology, and when we compared our data with theirs, they ran numbers for spill bucket testing out in California and containment sump testing, and their graphical data looks very much like ours. So we feel that we're kind of hitting the mark with we're understanding, and I think it's pretty intuitive that the first round of testing is not going to go well for most people. There's going to be issues discovered. A lot of repairs going to need to be made. New spill buckets going in. So that's what we can expect. But the bright side is things do get better over time. So I had with the RP1200, we did receive a lot of comments about considering going to a lower level of testing, and as the committee discussed that, we didn't feel that it was the best move for industry. However, we know that some states are considering allowing for low-level testing. State of Massachusetts in 2015 put out their new regulations, and they said that if you have a sensor in your sumps, you only need to test to the level that the sensor will activate. So, and if you don't have a sensor, you'll need to hydrostatically test your containment sumps to the top of the sump. So what we saw between January of 2015 and toward the end of last year was a lot of customers putting in sensors in their dispenser containment and tank top containment, so they didn't have to hydrostatically test their sumps to the top. Because as you know, once you get over the penetration fittings, that's where a lot of your problems are, and you're going to see failures. So if the option was there for them to test below the penetrations, they wanted that, so they put in sensors in Massachusetts so they wouldn't have to test above the penetrations. Is it a good thing? Is it a bad thing? Well, we'll see. We ran our containment sump and spill bucket testing data for Massachusetts in 2015. So not a lot, as you can see by the numbers here, we didn't have a whole lot of testing going on in 2015. Massachusetts put a due date of January 2017 to get all this testing done for all the owner-operators. They only gave them 2 years. A lot of the owner-operators thought that Massachusetts would back off and give them a little bit more time. They felt that 2 years was too short of a window to get all this testing statewide done, so a lot of owners did not test in 2015. So it's not really a good data set here to analyze. But we did run our numbers in 2016, and what I'd like to point out here is the passing percentages that we saw for your containment sumps. 95% passing rate, 96, 90, 98%, 99% passing rate for tank top sumps. Those drastically different from what we saw when we first started testing in Maryland. Now, what was that due to the lower level testing? It's my feeling that, these rates are indicative of, the testing only to the level that the sensor operates. Spill bucket testing was pretty high, 97% passing rate. That was kind of shocking as well. So there is, from the tester's standpoint, we do have a little bit of confusion, when going from state to state to do the testing. One state's regulations here say that, containment sumps need to be liquid tight for at least the bottom 3 inches in order for the leak detection sensors to work, and there can't be any penetrations below 3 inches. However, in the back of their regulations, they do say sump and containment testing should be done to the PEI RP 1200 protocol, which is filling it up to 4 inches above the highest penetration or sidewall seam. So it's just kind of interesting wording that, you only have to be liquid tight at the bottom, but we're going to need to test, above all the penetrations. Another state that Cromco deals with says doesn't matter, whether or not there's a sensor. All containment sump testing, we're going to fill the containment sumps to the top. For your existing sites, you're going to allow the test to run for 1 hour. However, for brand new installations, you're going to need to run the test for 24 hours. Another state in the New England area, again, fill the sumps to within 1 inch of the top of the sump, but they want a 3-hour test. So just pointing out here kind of gets confusing for state to state. Reading through another state's regulations, they say containment sumps shall be liquid tight on the sides, on the bottom, and at any penetrations. They don't reference any standard for doing containment sump testing, so if an owner contacted us, we have to think about, well, what do we apply in this case? Do we go with RP 1200? But it says the containment sump shall be liquid tight on the sides, the bottom, and any penetrations. In my interpretation, I'd have to fill that sump up to the top. But so again, some things to consider when you're writing your regulations. All right, any questions on the data presented? I'm sure there was. I presented similar data, at the tanks conferences in years past, and there's always been a lot of questions, and I'll try to get to a few, but we got several other presenters we need to get to. So I'll take time for 1 or 2 questions here.
Sure. So I have kind of one big picture question. So obviously cost seems to be a bigger concern for owners. So wondering if you can comment on the cost of doing the testing with RP1200 for an average site with, for instance, 3 spill buckets, 3 piping sumps, and 4 dispensers, if you could kind of ballpark that.
That's a tough question. I don't really get into the pricing. What I can tell you is that, Cromco doesn't, charge for the water disposal. A big cost of containment sump testing and spill bucket testing is the per gallon cost of the liquid water disposal. We roll that into a unit cost for either, we may charge per spill bucket or per containment sump, or, depending on the customer, we may have one lump sum charge for all the customers. So if I had to ballpark 3 tank top sumps, 4 dispenser sumps, and 4 spill buckets, and it's going to be a big ballpark, but I would say in the neighborhood of $2,500 in that area. But don't hold me to anything. I'm not the pricing guy here at Cromco.
Thanks. Let's see. So if you could clarify about the walkthrough inspections, do they apply to older containment sumps, so those that are not part of an interstitial system?
My understanding is that the monthly walkthrough inspections, if you have containment sumps, you're going to need to inspect them on an annual basis. Your spill buckets, you're going to need to visually inspect them on a monthly basis per the EPA regulations.
All right, and then I'll fit one more in quickly. Responding to what you were talking about recently, does the sensor trigger positive shutdown, or is it just an alarm?
Again, that's state-to-state regulations. Some states require positive shutdown, some states do not. So it just depends on the state that you're working in.
Okay, great. Well, and again, thanks everyone for all these questions. I'm going to hang on to them. So if we can't get them, on today's webinar, I'll work to find a way to get these answers to the questions out there.
All right, we just have a couple more slides, then we're going to turn it over to the next presenter. So, with all this containment testing that's been going on, owners are going to need to be prepared to make repairs, and the containment sump, the penetration boots are, a big problem that we run into with containment sump testing. We have specialized crews that do the repairs, and there's a number of manufacturers that provide repair options that are out there. There's Icon, there's Diversified Products Manufacturing, there's Bravo Systems. Those are the 3 that we're familiar with. We use all of them, and just share a couple photos, of different repairs that we've done in the past. But going to want to be prepared to, provide owners, operators, and testing companies with guidance on, what you're going to expect when it comes to containment repairs. Some states say 30 days. I'll be honest with you, to mobilize a crew to do containment sump repairs in 30 days can be challenging. So you're going to want to give the owners, in my suggestion, give the owners some latitude with these repairs, because there's going to be a lot coming down the pike in a very short time. So, be prepared to work with everybody on getting these repairs done. All right, I'm not a repair expert. I'm familiar with some of the repairs that we do, but if you have any questions on repairs, I'll take a question or two. If not, we'll turn it over to the next speaker.
Yeah, why don't we go ahead and hand it off to Lauren. Thank you so much, Ed. You covered a lot of information. You covered it really well, and we really appreciate it.
Thank you, everyone.
All right, folks. So, again, I'll hang on to some of the questions we didn't get to, but in the respect of time, we're going to go ahead and keep pushing forward here. So, our next speaker is Lawrence Swallenheim, and he is the Global Training and Assurance Manager for Franklin Fueling Systems. I'm going to go ahead and hand it off to Lauren.
Hey, folks. Again, thanks for showing up today. Ed, great job. A lot of good information. So Franklin Fueling Systems, give a little introduction. Again, we are a manufacturing company based in Madison, Wisconsin, nice and chilly Madison, Wisconsin. Again, we're the manufacturer of, for today's purposes, the Defender spill containment. We have a Defender overfill. And then we also have product lines which include our UPP pipe, APT piping, FE petrol submersibles, in-con tank monitors, as well as Healy and fill tight. So today we're going to discuss mainly the double wall Defender. I have some slides here from our newly updated training platform. So we do actually ask that all of our contractors maintain their certifications. So that would include both the installation and the testing of the bucket. And we just have a little disclaimer at the beginning of all our trainings there. One quick reminder on the, oops, skipped it there. What we'll cover here quick, I guess I got a little ahead of myself. So we're going to cover the interstice sensor options. What are the indications of liquid present and what are the actions that should be taken? We're going to talk about the specifics of testing our Defender spill bucket, both the single wall and the double wall interstice. Some best practices on maintenance, and then best practices on installation. And I'm going to talk a little bit about some of on those best practices, what you might see and why it would lead to an issue. So again, real quick on the safety side, again, we are dealing with the potential for spills and vapors when you're doing any of these inspections. Franklin Fueling is making a big push on the safety element. We'll have a project, High Vis, that's just been released, where we're providing information to both our contractors, distributors, and any customers. Again, just reminding of all the different elements of safety, lockout, tag out, again, to make sure you're handling your liquids and you're testing for vapors on a regular basis. We always want to remember to wear PPE, again, even if you are doing simple inspections. And then one of the most important is the lockout, tag out, or lockout, tag out, test out. And then all of our installation manuals will carry warnings and alerts on basically different steps of the processes of installation that could be a potential danger. So the double wall Defender series bucket is what we'll mainly focus on today. We offer two types of interstitial monitoring. Again, Ed alluded to these a little bit in his presentation. We offer an electronic version, and that version comes with our ULS, or Universal Liquid Sensor, installed, and that is factory installed inside the interstice of the, or inside the double wall section. The mechanical, we call it the integrity monitor. Again, back to Ed's presentation, you actually saw one, and you saw one actually being tested. Both of these, again, are going to alert you immediately to the presence of any liquid present, with the electronic probably being more easily detectable than actually having to inspect the mechanical. So the mechanical, or the I2 integrity monitor, again, it's going to use a float that's actually going to raise a dial to indicate any liquid present in the containment. If anytime the yellow dial is in the white, we've got little, if you look there, you can see we've got a 1 drop, 2 drops, or 3 drops. That just is an indication of the amount. We require, or we recommend as a manufacturer, anytime that yellow dial is in the white, that interstice be inspected and any fluids removed. And at that point, you would want to go ahead and then do a vacuum test to see if that interstice has been compromised. So to kind of reemphasize that, anytime that yellow dial is in the white, you've got something to inspect. There's no level of severity. There's no, if it's only two drops or 1, or if it's 2 drops or 3, you look at it, it's any time the dial moves into the white. On the electronic sensor monitoring, again, the ULS, or Universal Liquid Sensor, is connected to a tank monitor, be it the Incon Evo there that we manufacture, and/or they can be connected to a Veeder-Root or other monitoring consoles. And this is going to immediately, again, let you know of any liquid present. It will produce an alarm. It will record on an alarm history report depending on the operation of the console. And to the gentleman's question before, we can program our consoles, I can speak to the Incon only really, to actually do positive shutdown. Other options within the Incon, you can actually have it send an email out to a compliance group within the marketer, whoever's running the site. So there's various ways that information, not just the alarm populating on the screen or on a report, you can actually have it again sent out, or report sent out showing when the alarm occurred. And again, just as with the I2 monitor, any liquid present, so any alarm indication in here, you want to go out and verify that there is liquid present, that there's not an issue with the sensor or something else, and again, any liquid present needs to be removed and a vacuum test performed. And again, in the event that the vacuum test fails, the bucket will need to be replaced. So testing of the double wall and or single wall, we do recommend for the primary, again, a hydrostatic test on all models. And we're going to fill that container with water right up to just below our snowplow ring, mark our level, wait 1 hour, see if anything drops. Again, if any level drops, again, the test will fail. And then the bucket will need to be inspected and or replaced if there is an issue. On the vacuum, or on the interstice of the double wall, again, we've got an inspection port there where we have an actual tool, which is our T7107. We'll actually screw into that port. We want to connect a vacuum source and a manometer, and we want to apply vacuum until we hit 30 inches of water column, or 7.5 kiloparcels. We want to usually about a minute or so to allow that vacuum to stabilize, and then again, if we need to increase that vacuum or get it back into that up to the 30 inches of water column, we will apply the vacuum source if needed. After 5 minutes, if we are above 26 inches of water column or 6.46 kiloparcels, the test is successful. So basically, within 5 minutes of once you reach and is stabilized at 30 inches of water column, if you lose less than 4 inches of water column, you have passed. If you lose more than 4 inches of water column, the test is considered a fail, and the bucket will need to be replaced. Maintenance. So monthly maintenance, again, as a manufacturer, we kind of recommend some things, but again, we always will default to local code. But again, clean any dirt and debris from your snowplow rings. Inspect the cover gaskets and replace if necessary, and inspect the container for any liquid. Again, be it water or any other debris in there. Ed mentioned beer bottles and whatnot. You want to get all that stuff out of there. And so that's on a monthly basis. If you're using the I2 monitor, this is definitely a time you want to inspect that. Again, not having that electronic option, you actually have to physically go out and look at the monitor to see if you are seeing that the yellow dial in the white. And again, if that is the case, you need to remove the sensor and inspect the liquid and vacuum test. Again, looking for any damage done to the bucket inside any cuts or tears. Again, if you do have the interstice, you want to inspect it. That time, some folks may even, or there may even be a requirement to go and actually flip the sensor to confirm it is actually working and reading properly. And that, with the electronic version, there is just a plug that's right above that can be taken out, and the sensor's directly below that. It can be lifted up, flipped upside down, which should then trigger an alarm. And again, any of the complementary components, overfill prevention valves, filler vapor adapters, dust caps, and again, any other regulations per local EPA code. With our Defender, we also have a Defender overfill that I don't have a whole lot of time to go into today, but we have the ability with a worksheet and a what we call a magic wand. The Defender overfill is actually magnetically actuated. So we've got a method of using our testing tool along with the worksheet that allows a complete test of that overfill valve without the drop tube being removed. And that is sold in concert with our Defender spill bucket. So that may be another presentation for another training that Drew sets up in the future. Yearly, again, you want to inspect the interstitial monitoring equipment at that point. Again, you've probably done a monthly check on the actual I2 monitor, reviewed any alarm history with regarding the electronic, and record all those inspections per the local code. In some states, I used to live in North Carolina, they'll require the sensor status reports. Typically at startup, they want the okay, the alarm, and then the okay again. And depending, you might have to go a fourth sheet if you've got any other interstitials such as brine sensors on tanks, etc. And again, inspecting all of the related complementary components. There may be a requirement at that time to, again, test that overfill prevention as well. So, best practices regarding our spill buckets, installation height. This is a big one. The Defender spill bucket is a field adjustable and field replaceable. So as you can see there, the bucket sits inside of what we call a gravel guard. So that bucket in essence can be, if it was installed single wall, can be replaced double wall without breaking concrete. And in the event of you have a failed bucket, it can be also replaced without breaking concrete, which is a very large cost savings for the owner. The issue you see here is if the bucket is not properly set or the gravel guard was not properly raised high enough at install, what will happen is that snowplow ring and gravel guard will end up pushing down in the bucket. What happens is as that gravel guard, the load pushes down, the bucket's on the riser, and what happens, you'll start to see the inner bucket push in. If you do any inspections on a Defender bucket and you see that bucket starting to bow in like that, there's more than likely an issue with install, and more times than not, the interstice will more than likely fail. In that case, there may potentially be an issue where concrete will need to be broken and that bucket installed properly. The sensor core grip, that core grip does come in installed by our factory prior to leaving it and is tested. If that is damaged in any way, or if you start to disturb it and move it around, you can try to kind of see if I can get my laser pointer to work here for me. So you can see right here that is actually a little grommet that is factory sealed. If that is disturbed and is damaged in any way or heaven forbid broken off, that creates about a half-inch hole inside that interstice, and therefore that bucket will never pass and will need to be replaced. Again, we don't want any cuts or any damage into the gravel guard, with the minor exception of the hole drilled for a conduit entrance for our electronic sensor, and that can be we'll approve anywhere on the side here. You're typically on this side, and actually can come in through the bottom, and then that's sealed with a compression nut and or compression gland. So with that is all I have. I'm more than happy to take any questions on the Defender spill bucket, or if you do have any questions on the overfill, I can answer those. In addition, I was just at an install of a beta test. We will be coming out with a grade level Defender series probably later on this year.
Great. Well, I do have a question in response to one of your last slides there. So a liquid gauge or sensor in the spill bucket interstice does not monitor the integrity of both walls, which means a bucket must have vacuum in order to avoid the 3-year test. Is that correct?
Not according to our recommendations. We'll accept the hydrostatic test. If the interior bucket is broken at the bottom, it should catch into the interstice. Okay.
Thanks for the clarification. And yeah,
if you look here, just to kind of answer that, so if you look here, if you look at where my line is, okay, that's your primary. and then your interstice is out here. So if say it was damaged up here and this was filled with water, that water would leak down in and trigger the sensor.
Okay.
Is that clear enough? Can you guys see that? It might be, you can kind of see that the entire double wall goes all the way up to these bolts up here.
All right, and if there's a follow-up to that question that was just sent to me, feel free to send the follow-up for further clarification. Lauren was right in saying that, NEIWPCC, we do plan actually on both overfill and repair. We have some webinar trainings sort of down the road that we're in the process of planning right now, so more to come on these two topics. I think that's all for questions right now.
Drew, I see one that came in here I would like to address.
Yeah,
the question
absolutely.
is, does Franklin Fueling accept any repairs on spill buckets, or should they be replaced? They should be replaced. The fact of the matter is, as a manufacturer, we have, any modifications also will deny warranty. The fact of the matter, it's really hard for us to judge how the repair was taking place, who took it, and then at that point, if repairs are done, they're at the mercy of the marketer or the contractor that did them. Franklin will not back that under warranty. So as a manufacturer stance, if there is a damage to the bucket, it needs to be replaced.
Okay, and then following up about the question previously, so if the secondary wall is damaged, then is it true that the liquid gauge won't register liquid?
If the secondary wall is damaged, so the exterior secondary wall, so if you look here, so if you're looking out here or in here, yeah, because anything that's going to get in here, if you see it, it's going to fall down into this little pit here. So there's a low point that's created. So any liquid that does get into this bucket is going to travel down into this little pocket. If this exterior is completely thrashed, I think liquid, depending on, that's, again, we're talking about a scenario here, but depending on what happened, more likely the water was going to get to that point. Now, the fact of the matter is, if you were to vacuum test it, you would catch that in a minute. But right. I guess I'm trying to understand a question. If this inner wall is damaged, and there's enough fluid in there to spill into the secondary, yes. If it's damaged down here, it's definitely going to get in. But if it's damaged up here and you don't have any, and you do any periodic vacuum testing, like according to the regulations, you would catch that.
Right.
At a test, unless, again, the bucket filled with water to the point where it penetrates.
Great. Yeah, I think that answers it well. Thank you. Okay, folks, feel free. I think we'll go ahead and move on. Feel free, if you do have questions that pop up, in the next few minutes for Lauren, send them my way or to him, and we'll work to get those answered. Thank you so much, Lauren. I think it was a great example of some specific equipment for us to talk about. So thanks for sharing.
Thank you.
All right, so I'm going to go ahead and hand it off to Natalie Creed. She's the Hazardous Waste Compliance Manager at Idaho DEQ. We're going to get into sort of the second part of today's training, and do just want to make a clarification to make it clear that this part of the training doesn't represent a specific recommendation from EPA. We were thinking for this training, though, that we did want to provide sort of a glimpse of what a couple states have done in terms of how they've considered and what they've done in regard to handling of testing fluid after hydrostatic tests. So again, not really a recommendation from EPA on this, but some examples from the states for you all to hear about and learn from. So without further ado, I'm going to go ahead and hand it off to Natalie Creed.
Hi, everybody. My name is Natalie Creed. Like Drew said, I'm with the Idaho Department of Environmental Quality in Boise, Idaho. And I'll be talking about just Idaho's policy regarding management of the hydrostatic test fluids from testing the spill buckets and sumps. Last year, I was approached by our underground storage tank program manager, Christy Louder, to help develop our, what our policy would be in Idaho for management of these fluids. And after a lot of discussions between our programs and looking online at what other states have said, my takeaway was that the states can differ quite a bit on their policies on this and on whether the hazardous waste regulations apply to the hydrostatic test fluids or not. Or they might still be developing their policies too, depending on where they're at with their requirements for these tests. I'm hopeful that at some point EPA headquarters will provide some direction so that we might have more consistency. But at this time, like Drew mentioned, everybody needs to check with their state. The owners, operators, contractors, you need to check with your state that you're operating in to find out what the rules are and how they apply to your situation. Idaho has taken one approach, and you'll hear from Heather in Missouri about how they've taken a different approach. And I'll talk about how we got to ours. And let's see, Drew, do I have my presentation up yet?
You're still on Lauren's, so if you go to the little drop-down arrow on the top, there you go.
Okay, got it. Thank you. Okay, so the approach that Idaho took is that residues in the fluids can cause the test fluids to be regulated as hazardous waste. And where we focused our discussions on was there's an exemption in the hazardous waste regulations for petroleum contaminated media and debris, and by media I mean soil and groundwater, in the instances where a cleanup is taking place for a release from a petroleum underground storage tank. And the media and debris is excluded from the hazardous waste rules if it only exhibits certain characteristics and provided the cleanup is subject to the corrective action requirements in 40 CFR Part 280. So we took a look at that, and based on our interpretation and reading some EPA interpretations, we felt that we could not interpret it to mean that the test fluids are exempt. Because it's not a release or a leak from a tank system per se, it's more routine testing and maintenance. Again, other states can differ on that. Some states have said that these fluids can be exempt based on that rule. So just again, check with your state. But that's what we took a look at, and we had discussions, again, between our underground storage tank program and our hazardous waste program. We talked to our Attorney General's office, and we talked to our EPA Region 10 in Seattle. And so the approach that we took is that the fluids are subject to a hazardous waste determination under RCRA, and that the contaminants in the fluids can potentially cause it to be regulated as a hazardous waste. And just to quickly go through the recommendations then that we're giving to the owners and operators and contractors leading up to this requirement, like Drew and, Ed and Lauren said, we highly recommend that the spill buckets and sumps be cleaned out and inspected prior to doing the test to keep the fluids as clean as possible. We recommend, but we don't require, that for the test that you use a new test fluid each time. And then if you're going to containerize the fluids after they've been used for a test, we'd like them to label them and date them until they can do their hazardous waste determination and figure out how it's regulated. So under RCRA, the hazardous waste rules, a generator of a waste is required to determine if it's hazardous waste or not, and we call that the hazardous waste determination. It's required under 40 CFR Part 262.11. And we're advising everybody to include this step in their planning ahead of time, and that we can help with any questions. So the main things that we would be concerned about with these hydrostatic test fluids potentially being hazardous would be ignitability or the characteristic of toxicity. Ignitability is unlikely, probably because of the amount of water versus fuel, but it's still something to consider. With gasoline. And with toxicity, what we're concerned about, of course, is the benzene. And there's a specific test under the hazardous waste rules that we use, and there's a regulatory limit of 1/2 of a part per million or 0.5 milligrams per liter for benzene. If it's over that, in Idaho, it would be regulated as a hazardous waste in these situations. Now, if testing shows that the fluids are non-hazardous, there are several options. It could potentially be shipped to a wastewater treatment plant if they'll accept it. It could be discharged into a facility's sewer line if it's in compliance with their permit, and again, if their wastewater treatment plant agrees to accept it. There are some solid waste landfills that can accept liquids and solidify them prior to placing them in a landfill. We have a commercial solid waste landfill in Idaho called Idaho Waste Systems that can do that. And we're also telling folks that they can't dispose of the test fluids, even if you've determined that they're non-hazardous. We're not going to allow those to be disposed onto the ground or into surface water, into storm drains, or anything like that. If as a result of the testing it's determined that it's hazardous due to benzene or anything else, then of course they would be required to follow the hazardous waste requirements. And there are rules for dating, labeling, keeping containers closed, how long you keep them on site based on your generator status, that kind of thing until you ship it off site. And you would have to use a hazardous waste transporter and be in compliance with the DOT requirements. Or you might be able to check again with your wastewater treatment plant to see if that's also an option. Or another option is to send it off for reclamation, where the petroleum constituents are recovered to continue to be used as a fuel. Or also a generator can choose to go ahead and ship it off-site as hazardous waste, using a hazardous waste transporter and shipping it to a hazardous waste treatment storage disposal facility. Another question that's come up for us is who will we say is the generator of the waste? Is it the owner or operator of the gas station, or is it the contractor that they hire to do the testing? Under the hazardous waste rules, more than one person can actually be the generator. You can have co-generators, or one entity can choose to be the generator, and so we're recommending that everybody come to agreement if they're hiring somebody to do these tests. They should agree on who will assume the duties of being the generator and who will make sure that any proper testing takes place, and then ultimate disposal, and who will keep all of the records and paperwork associated with that. So that's something that they need to talk about and know who is going to take on those responsibilities. And then our underground storage tank program is letting folks know, of course, like has already been talked about today, that there are other methods where they could avoid having to test and manage the fluids potentially as hazardous waste, the vacuum testing method, or the double-walled sumps, where the testing is not required. So that's about all that I have, unless anybody has any questions. So we're taking a pretty conservative approach in Idaho. And again, I would prefer to take a different approach at some point if we can, like Heather will talk about in Missouri. She raises some really good questions. So I'm hopeful that at some point we might hear some different direction from EPA on this. But that's the path we're taking at the moment in Idaho.
Awesome. Well, thank you, Natalie, and you actually did a great job of answering a couple of the questions that came up. You answered in your presentation, which is perfect. I do have one that's pretty specific, and I'll try to read it off accurately here. So the question is, if sumps or buckets are cleaned, and excuse me if you already went over this, if sumps or buckets are cleaned prior to filling with clean water for the hydrostatic test, would the test water be considered a de minimis loss and therefore allow the tester or owner-operator to dispose of it in a storm or sewer drain?
Definitely not into a storm drain, even if they do determine that it's non-hazardous. That's a policy we've implemented. And unfortunately, even if they've wiped out the spill bucket or sump really well with absorbent pads or something like that, because the benzene is regulated in such low parts per million levels, the 0.5 milligrams per liter, it would be difficult to know if the fluids were below that or not. So for now, we're saying it would be required to test it, but I'm hopeful that at some point maybe we can take an approach with generator knowledge where we wouldn't have to say that. And also that raises another issue of whether the test fluids are clean or not. We would, again, allow test fluids to be reused in Idaho. It would still be a product as long as it's being reused, but we're recommending that clean test fluid is used each time. So hopefully keep it from characterizing as a hazardous waste.
Okay, that's a great answer. Thank you. I don't see any other questions coming in right now. Folks, if things do pop up and toward the end here, feel free to send them my way or directly to Natalie if you'd like. So I'm going to go ahead, and before we go to Heather, thank you so much, Natalie, for helping us out with the training today, giving us a good example of what's going on in your state. So I'm going to go ahead and move along to our final speaker for the day. Heather Peters works on UST compliance and technology with Missouri DNR. And Heather, take it away when you are ready.
Drew, this is Ed. I think he gave it to me.
I think I got it back now. Can you hear me?
All right. Yep, sorry about that, folks. Go ahead, Heather.
Okay. This is Heather Peters. I am with the Missouri Department of Natural Resources. I'm on the tank side of our program, and so what we wanted to do today was, first off, you're going to see that states can do this in a lot of different ways. I think they picked Natalie and I because we are on pretty opposite ends of the spectrum on how we're handling this. But I also wanted to explain how we got to where we were and how we worked through those decisions so that when you as regulators or you as interested parties go back to your state and try to figure this out, we'll give you some ideas about the things that we discuss and the questions we ask to get through this process. So the way this started for us in Missouri is, of course, we began our underground storage tank rulemaking process. And one of the first things that came up was if you are going to require us to do containment sump testing, you are going to come up with a guidance document before we finalize that rule. So word of the warning to all the states that are working on that process, that was pretty clear message to us that we would not get a rule through unless we had some sort of guidance. And the next thing is I would recommend you start very early because it required a lot of coordination and it required involvement of a lot of different parties and regulated medias and different programs within our department. We did start with our water side, and depending on how your state's set up, we used our site permitting folks, water treatment permitting folks, and it ended up involving quite a few different people. And then on our hazardous waste side, we did have to look at a lot of different factors under the RCRA regulations. So make sure you involve all of those parties early because they're all going to have a lot of different things to weigh in and advice to offer. And last but by no means least, you might want to also consult your Department of Transportation. I'm not going to delve into that today very much, but each state probably has their own requirements about how this material can be transported and what the requirements are for those. So I'm not going to get into this in great detail. I think Natalie did a great job of covering it, but there is a requirement to do hazardous waste determinations. But there are some exemptions depending on what your material is. And so one of the things that we discussed with our RCRA folks was the benzene exemption. And the benzene exemption talks about how anything that's petroleum contaminated media that is subject to some sort of corrective action under the UST rules is not a hazardous waste. Specifically for some certain characteristics, benzene is included. And what we discussed was that we believed that if we find water or product in a required containment sump, one that's going to require this testing, they do have to address it. They have to do something with it. They have to remove the water. They not only have to remove product, but also figure out where it comes from. So we determined that we believe these wastes were subject to this specific exemption. Again, your state may have different answers. It is definitely something to discuss. So we decided that yes, if it is product, it's a leak from the primary system, and it has to be addressed. Also, if there's water, like I said, it has to be cleaned out. So no matter what, you have to do something. But be aware that is just for benzene. That specific exemption does not apply to ignitability or some of the other characteristics. Benzene is the one we're probably looking at, though, for our petroleum. It also applies to the absorbent materials, and we're not going to go into great detail today, but just be aware that we handle the absorbent materials slightly differently. but they are a key part of this discussion. We do not recommend that you let them dry in any sort of containment sump, whether it's under a dispenser or in the tank top. They should dry in a protected area, but we do recommend drying them before trying to dispose of them. And we have a lot of additional guidance on this. So we started with our water program, and with our water program, we discussed specifically first the use of an on-site oil water separator. For a lot of our larger facilities, like our truck stops, they do have on-site oil water separators. And so the question came up, can they use their on-site oil water separator to dispose of the water when they are done with all of these tests? And the answer for most of ours was yes. As long as the oil water separator has been properly operated, they can dispose of it through our oil water separator. And I'm going to get into a little bit more detail, I think, on that later. Again, we discussed whether or not we could do on-site disposal of clean water, and you needed to ask where and how and what those limitations were, whether they could dispose of it in the sanitary sewer. And the key question that came up for both water and for our hazardous waste program was, is this water clean? So when we entered into this discussion, in the tank world, we're used to dealing with just our tank sites. But of course, our partners in the water programs and in the RCRA programs deal with a lot of different substances and a lot of different facilities. So one of the first key points that we started with is we're talking about our gas stations. And so we did limit our guidance specifically to the gas stations because we know what those substances are and we know what those products are that we have at those facilities. So we're not talking about a whole large range of chemicals of concern and products. We were talking specifically about gas and diesel for the most part. One of the key points that we also discussed was something that Ed went over very clearly, and I thought he did a great job covering in his discussion of RP 1200, was that before you do your sump test, that containment sump is supposed to be cleaned. So we have a clean sump before we start, and we are dealing with products that we understand and we know. So as we do these tests, and we see water standing in these areas, and we're not talking about water that's flowing and that's moving at some sort of high rate, it's water that's standing in a containment sump, it's pretty easy to identify petroleum on water, especially when it's standing. We're going to see a sheen, we're going to see some sort of measurable product. And then what they did next is we recommended using petroleum absorbent pads if they saw any sort of sheen or any sort of identifiable petroleum in these areas. So when we defined what clean water was, we talked about it being water in gas stations or at these gas stations in the containment sumps with no visible product and no visible sheen on it. So we narrowed down the scope of our document and our determination and tied it to these specific points. And we found this to be very helpful in moving forward with our discussions with both our RCRA folks and our water folks. So it came back, if water is clean, so now we figured out what we thought water being clean from these test procedures would be. It's been cleaned, there's no sheen when we're done. What some of our options that our water program came up with was that it could be land applied. Now, that doesn't mean dumping it into a ditch, that doesn't mean dumping it somewhere where it can run off, but basically they could water the grass with it if that's what they wanted to do. As long as it was clean and we'd already gotten through that step, then they could go ahead and water all their landscaping with it, and that was okay. The sanitary sewer discharge was allowed, but since those sanitary sewer discharges are regulated and they're under the authority of the recipient of that discharge, you did have to ask for permission and make sure it was okay in that city or in that sanitary sewer district that you could discharge your clean water through their sanitary sewer. As I said, we would allow our water folks that it was fine to go ahead and run it through their oil water separator. Of course, the key on this one is they can't be using any sort of soap or surfactant. We're going on the assumption that we're going to have a petroleum layer and a water layer, if they have any. Again, we think it's already been cleaned, though. And of course, last but by no means least, if you want to handle it as a hazardous waste and do many of the things that Natalie just discussed, that is still an option on the table, and that is still a perfectly viable option on how to handle that water disposal. So again, what we were talking about was doing test water in these containment sumps, theoretically mostly clean. And as Ed discussed and mentioned, we considered whether or not you could reuse that test water. And our hazardous waste folks came to the same conclusion that Natalie mentioned just now, which is as long as it is still being reused as a test water, as long as it is still clean enough for you to take from site to site, then it is still a product, and it's not even to be considered a waste yet at that point. Of course, one of the big things that our owners and operators discussed when this came up was that they should be consulted on that test water that's being used at their site, and they can always request that they have only clean water used at their site or water from their facilities only. So when the test water comes back, though, you do have this test vessel, and they're going to continue moving it around from facility to facility, theoretically, and they're going to keep using it to test multiple sumps. The contractor has many, if not all, of the same options for disposal that we just went through for the owners and operators at their site. Because, of course, this contractor is going to bring it back at some point. They're going to look at this water, and at some point they're going to have to decide whether it continued to be used. But since we had already determined it was exempt from the benzene testing, and again, we're treating it as clean water, so they still have to potentially clean it, the contractor has many of the same disposal options. But one of the things to consider when you're looking at this test water in these tanker systems is, again, what does your DOT say? So I do recommend before anyone proceeds on this step, they definitely talk to their local DOT. Be aware if you cross state lines, these answers may be completely different, and that may change what your disposal options are. It may change what your handling options are. So we definitely recommend talking to your local DOTs, any DOTs in the area that you are operating, and of course the federal one if you're crossing state lines potentially too. Some of the other questions that we'd recommend discussing are if you have a tanker and you are using some sort of cleaning mechanism, whether they are cleaning it as they go between sites, whether they are skimming it as they go between sites, whether they're just putting absorbent materials on it, does that change your state's answer on whether or not it's a hazardous waste? Does it change the status of that tanker en route? Are they doing some sort of RCRA treatment? Are they doing some sort of resource recovery? Is there something that they are doing in that process that also changes how they are reviewed, both under hazardous waste and under DOT? So again, these are questions we'd recommend you bring up as you are looking for your options to try to create guidance for your state. When we had these meetings, and this was not a fast process, the more people you get involved, the better ideas you get, but sometimes it takes a little while longer. Some of the things that came up in these discussions were big picture items that we were looking at. Is the guidance that we're coming up with really serving a detailed environmental protection? Are we really creating a benefit? And one of the things that the owners and operators brought up, validly so, was that we're talking about containment sumps at operating gas stations. They have surface drips, they're going to have leaks, they have spills, and we know that at the end of the day when they close those tanks, they're going to have to do sampling and closure to address any of those things. Is this adding to what is being found at the site or what is being released at the site? Is it providing an extra benefit that is necessary? Of course, when we were talking about this, one of the discussions that came up was, is it cost effective? What are we talking about financially? We're already adding a lot of new requirements under these underground storage tank rules, and we're adding a containment sump test piece. Is the disposal of the water going to be more expensive than the test in the first place? And I don't know about in other states, but in Missouri, it's typically our underground storage tank inspectors that are at our underground storage tank sites. Unless something's gone wrong, we don't have a lot of other inspectors at these sites. Not necessarily. Some of our bigger sites, of course, do, and some of our multi-use facilities do. But for our just regular gas stations, they may not have a whole lot of RCRA inspectors or water inspectors at their site. How much additional oversight are you adding to your state when you come up with your final guidance document? The next thing that came up was, all along, our sites have been disposing of water and residues. I don't know how many of you still have these spill buckets in your state. We still have a few floating around. It had a pump in the bottom and a hose that didn't stick out more than, what, a foot out of the top of the spill bucket. We know what they were intending to use that for. We know how they were disposing of it. It was running across the ground. And they've been doing different types of work and different types of processes at their sites all along. They've been spraying off their dispensers and getting water. They've been getting water in their spill buckets because the lid's cracked. Whatever the case may be, how have they been doing it all along? And with our owners and operators, they got involved in this process and they got involved in these discussions because they want to do the right thing. When we create a final guidance document, when we create a final rule, they want to try to do the right thing. We don't want to make it so that it is just impossible or extremely difficult for them to meet. We want to give them an option that's right, that's the best, but is also practical for them to apply day in and day out at their sites. So what we found is the simpler we kept it, the easier that worked. And big picture, did it make sense when we were looking at the site as a whole and the big picture as a whole? And then, of course, as regulators, some of the things we were discussing, if they dispose of it on site the wrong way right now, how will we know? Are we going out to these sites? Are we watching for disposal? Probably not. How often are they doing it? They're not telling us that they're doing these containment sumps typically, at least in our state they don't. One of the things we did do when we created our guidance document is we did tailor it specifically for our gas stations. So we did design it for primarily gas and diesel applications. If we have hazardous substance facilities or even some of our maintenance facilities that have other substances, this is not the applicable guidance document for them. But we did want to make sure that doing it right or doing it the best way that they could wasn't cost prohibitive, that it didn't discourage them from doing the right thing. We wanted to try to come up with some options where they would actually follow through on what we were doing. And last, but by no means least, we want to step back and think logically and practically. At the end of the day, our goal is to prevent petroleum from entering the environment. Ideally, I hope that's what we're shooting for. And so when we were developing our guidance document, did we come up with an answer that when implemented in the real world would be practical? And what we meant by that is, if we set the goal so high and we make it so expensive, we know that there's a good chance that potentially they might not be doing that. But if we can come up with real options that really do try to prevent petroleum from entering the environment, and we come up with ways that are relatively easy for them to do, then at the end of the day, we're probably preventing more petroleum from entering the environment than we would have with some of the more cost-prohibitive options. So we wanted to make sure that our answer met the goal when implemented in the real world. We did come up with our guidance document. There's a link for it when these are out on our webpage. And the last thing I want to mention is if you have found any of this information today from all of our speakers helpful, SWAMO does have an underground storage tank workshop. It is coming up in May. It's in Louisville, Kentucky. There are going to be actually 2 sessions on this topic at that training. There will be an entire session on testing procedures, and there is an entire session that is going to be on the waste disposal and the water disposal from these, where we will have an opportunity to not just hear from 1 or 2 states, but get to bring in all of the states, hear what everyone is doing, hear what their questions are, and then on top of that, the SWAMO is also working to develop a white paper specifically on this topic as well. So we would definitely invite you and encourage you to attend the sessions in Louisville, because the more of you that are out there providing your expertise, the better off we'll be. And with that, that is all I have today.
All right, Heather, well, thank you so much. Very comprehensive and well covered in a short period of time. Folks, just a reminder, don't have any questions from any of you yet for Heather. So what I'll do right now, actually, I did just get a message from, I have Tim Smith, he's on the webinar from EPA Office of Underground Storage Tanks, and he was hoping to respond to what Natalie had brought up previously about EPA guidance. So I'm going to see if I can unmute Tim to respond to that question. Tim, are you there?
Hi, Drew. This is Tim. Can you hear me?
Yes.
Great, great. Hey, yeah, when Natalie had mentioned EPA guidance, I definitely kicked into gear. This particular webinar, it's kind of atypical. Typically, for these webinars, we already have tried and proven test procedures and just how inspectors are doing things. This one is kind of a cart before the horse. The planning team, we try to get the information out there. There's a lot of information basically floating around in this topic. It's kind of a dynamic issue, something that EPA, we are trying to put guidance for ourselves when implementing the requirement in Indian country. We are the responsible implementing agency. So this issue, and Natalie asked for guidance from EPA, and it is coming. But there are some issues that we do need to address, and that I think helpfully something that would be beneficial from EPA. It's not ALS, but it's the RCRA program that ALS is working with. I think it's the issue about the test fluid. Is it considered hazardous or not? I think that, and having that information would help states make their decisions on how to address this issue. Heather mentioned that very soon at the ASWAMO meeting, we're going to be talking about this issue. There are going to be a lot of perspectives. States are revising their regulations coming in after EPA. We wrote our 2015 guidance. There are some procedures in place prior to the 2015 regulation. Are those consistent with EPA's focus or our requirements? The answer may not be yes in all cases. Everything's going to pretty much be on the table, and I think the hottest issue is going to be that sump water disposal. So stay tuned, and hopefully EPA, we can pull everything together, and at least from the perspective of implementing it in Indian country, we can provide some guidance in that respect. Ed, I wanted to talk about something that he mentioned. He mentioned about sumps and testing. Some states have regulatory requirements in place about the sensors being in place. Owners and operators don't have to test above those sensors. All of those regulatory requirements, I believe they predate the federal 2015 regulations. So we'll need to look at those to see if those are consistent. Like I said, this whole topic is dynamic, and there are a lot of moving parts, but hopefully someday soon we'll have answers to each one of these, but there are a whole lot of issues. We wanted to get this webinar out there to discuss the issues, to put these thoughts on your mind as you're developing your program. Unfortunately, we don't have those bullets that say you can or can't do that at this point, but like I said, hopefully we will be providing, EPA, we will be providing some additional information to help you make these decisions.
All right. Well, thank you so much for following up there, Tim. Definitely appreciate that information. Thanks really so much to our speakers, for helping plan and then put on just a really well-rounded webinar, as Tim was just saying. I know I wasn't able to facilitate answers to all the great questions that came in. There were so many that we just couldn't get to them all. But I do have some contact info up for you here. Our speakers encouraged me to, share their emails. So if you did want to follow up with them, or you could send questions to me, and I could reach out to, as Tim mentioned, folks from the planning team or folks from ALST to help you get the answers to your questions. Just a friendly reminder, we do have that survey. Any of you that wanted to confirm that you did attend today, go ahead and take the survey when you log out of the webinar today and provide any feedback you do have for us. And then just following up, we do have a website. NEIWPCC posts our recordings to the webinars there, so you can see that the long link is there, or if you just want to go to NEIWPCC, NEIWPCC.org, navigate through our site to find our UST pages, and there's a whole webinar archive of previous trainings, and this training, like I said, should be up within the next couple of weeks. If any questions do come up, feel free. I encourage you to contact me through Youngs, cyoungs@NEIWPCC.org with any other questions. And again, just following up on the speakers today, we do have both repair and overfill also as upcoming training. So I know those topics were kind of discussed briefly today, and look forward to bringing you more training on those. So again, I'm speaking for everyone that's out there on mute right now, but thanks so much to our speakers for a great training today, and everybody have a great rest of your week. Thanks so much.